In this video, we're going to be talking about the multiplicative rule of probability. And to start that off, we're going to first review our conditional probability formula. And our formula for conditional probability was the probability of an event A happening, given an event B has already happened, is equal to the probability of A intersect B, and that whole thing divided by the probability of B. And remember, what this is trying to do for us is it's trying to find how often A happens and B happen at the same time, so the intersection of A and B, and then we're going to divide it by the probability of B, which is basically meaning we're zooming in on just the probability of event B happening, and then treating that as our entire sample space, and then looking at how often A happens inside of that sample space. So the next step that we're going to be doing to get to our multiplicative rule of probability is we're just going to rearrange this formula a little bit. And what we're going to do is we're just going to multiply both sides by the probability of B. So we're going to have the probability of B on the right side, which is going to cancel out the probability of B on the bottom of our fraction, and the probability of B on our left side. So now we're going to get the formula where we have the probability of A intersect B is equal to the probability of B times the probability of A given B. And since we know that the probability of A intersect B is just equal to the probability of B intersect A, we can also rewrite our formula up here a little bit and give us probability of A times the probability of B given A. So we can actually say the probability of A intersect B is equal to the probability of A times the probability of B given A, or it's equal to the probability of B times the probability of A given B. And that's what we're going to consider our multiplicative rule of probability. The probability that A intersect B is equal to the probability of A times the probability of B given A, or the probability of B times the probability of A given B. So now that we have the basic form for our multiplicative rule of probability, let's walk through how we can use it for a simple card problem. So our problem is going to be, what is the probability that we draw two aces in two cards? So to break this problem down, we have our first step, which is the probability that we draw an ace. So we're drawing an ace in one card. So if we think about that, that's just equal to the number of aces that we have in our deck. So we have 4 aces divided by the total number of cards that we have in our deck, so 52. So the probability of drawing an ace in one card is 4 out of 52. Now we have the probability that we draw an ace in one card, given that we've already drawn an ace. In one card. So if you think about that, that's just equal to the number of aces we have left in our deck. So we have 3 aces left, and the size of our deck left. So since we have 52 cards before, we've taken one of those out. We now have 51 cards left on our deck. So we now have all the pieces that we need to actually calculate the probability of drawing 2 aces in 2 cards. So we have the probability of A intersect B. So we draw 1 ace in our first card, and we draw 1 ace in our second card, and we have 2 total aces, is equal to the probability that we draw an ace, so the probability of A, times the probability that we draw another ace, given we've already drawn our first ace. So probability of B given A, which is equal to the probability of A, which is our 4 out of 52, times our probability that we draw a second ace, given that we've already drawn that first one, so our 3 out of 51. So our probability for that is just going to be equal to the two tops multiplied together, so 4 times 3, over the two bottoms, so 52 times 51, which is equal to 12 divided by 2,652. Or if we simplify that, we get 1 out of 221. So that means if we're dealt 2 cards, we would expect to get 2 aces every 221 times, or average 2 aces every 221 times we're dealt 2 cards from a 52 card deck.